Okay, pre-calculus, this is the first video for the 4.7 notes. We're doing inverse trig. We've done inverse trig with the calculator at the beginning of this unit, but remember that inverse trig, it has that little raised to the -1, which does not mean reciprocal. It does mean inverse in this case. Now, when we're doing inverse trig, though, without a calculator, which is our goal today, this is where we have to be very aware of the range of our inverse trig functions. So basically, what the range is telling me is what I am allowed to put as an answer. So what this is saying is if I'm doing an inverse sine problem, my answers can only lie between -π/2 and π/2. So that would be -π/2. Remember, that's just a rotation the other way. So to basically down 90 degrees, that's -π/2 radians, and +π/2 would be up to 90 degrees. So my answer, if I'm doing an inverse sine problem, is only allowed to be between -π/2 and +π/2. I'll discuss in a little bit why that is. So basically, I cannot get an answer as far as the unit circle goes on the left side. That's actually going to be the same pretty much for tangent. If I'm doing an inverse tangent problem, same thing. My answer has to be between -π/2 and π/2. So this applies to inverse tangent as well. And again, I'll explain in just a little bit why we have these restrictions. Inverse cosine, the answer has to be between 0 and pi. So 0 radians and pi radians. Basically, it's saying an inverse cosine problem can only have answers between those angles, which means I don't use stuff in the bottom. So for inverse sine and inverse tangent, basically we cross out the left side, our answer has to be on the right side. For inverse cosine, we cross out the bottom. Now, a little bit about why this is. This is a little bit on the theory here. If I asked for you to do the inverse sine of, we'll say 1/2 without a calculator. So what this is asking me is what angle, if I think of it like regular trig, it would be the sine of what angle is 1/2. So inverse trig, remember, gives me angles. It's asking me basically what angle would I get? Well, looking at our special right triangles, it would be a 30-degree angle that has a sine, or opposite, of 1/2. So that would mean a 30-degree angle in the first quadrant, or in radians, π/6. But here's the issue. If I do not restrict my domain, or excuse me, my range, well, the sine is also equal to, down here, the sine is also equal to +1/2 at this 30-degree reference, but that's an angle of 5π/6. So π/6 works, 5π/6 works. Now, the ones down below wouldn't work because sine's negative down there, but I also could do a full rotation and land back here, which would give me 13π/6. Oops. And I could keep on doing this. I could spin and land over here. I could keep doing this forever. I could always keep spinning and getting more answers. Why is this an issue? Well, if I'm saying that inverse sine is a function, that's the key word here, function function can only have one output. Inverse sine of 1/2 could actually have infinitely many outputs. So basically mathematicians realized this was going to be a problem. We can't say inverse sine of 1/2 on a calculator and let it spit out infinitely many answers. So mathematicians said, all right, let's just kind of fudge the numbers. Let's only look for inverse sine between these two angles, -pi/2 and pi/2. That covers negative possibilities down on the bottom. It covers positive possibilities up top. For inverse cosine, though, that didn't work because cosine is positive in the first and fourth quadrants. So they had to change their idea, and they said, oh, wait, cosine's positive in the first, cosine's negative in the second. That covers all our possibilities, and now we're good. So basically, this whole restricting our range thing is basically so we don't break calculators, so that they stay functional, that we get one single output. So that's the theory behind it. Basically, the big thing to remember is what do you cross out? So I'm going to be asking that on every single question that we do here. So I just have a whole series of problems of these. There we go. Where we're just going to practice this. So before you even look at the number, you first look at what inverse trig am I doing? On 1A, I'm doing inverse cosine. Inverse cosine, remember it's asking me what angle would give me -1/2. But inverse cosine, I immediately cross out the bottom. And this is only when I'm doing inverse trig. Now I ask myself, what angle would give me 1/2 for the cosine? Well, the angle that has 1/2 for cosine for the adjacent, if we go all the way back to our angles here, let me erase all this other stuff. The angle that has, 1/2, get rid of these. The angle that has 1/2 for the adjacent is the 60-degree angle. 60-degree has 1/2 for its adjacent side. So I know it's a 60-degree reference. Since it's negative, cosine is negative in the second quadrant. So basically I know that I'm going to have a 60-degree angle such that the adjacent is 1/2, but negative. And then the final answer is to tell me what this angle actually is. Well, that angle is 1/6, 2/6, 3/6, 4/6, 4 pi over 6, which reduces to 2 pi over 3. Again, it actually is true that cosine is also negative down here in the third quadrant, but that would give me more than one output to this function. I don't want that. For letter B, this one wants inverse sine. So before I even look at the number, I go, all right, inverse sine, I cross out the left side. Now I ask myself, what angle has an opposite, since I'm doing sine, of √3/2? The angle that has an opposite of √3/2 is also a 60-degree angle. So this is another 60-degree reference, and since it's negative, sine is negative down in the fourth quadrant. So it's a 60-degree reference. And now, according to the rule, I'm not going to rotate in the positive direction. That's not what I'm going to do. According to the rule, I have to actually rotate negative to there. That negative rotation is -1/6, 2/6. So -2 pi over 6 or -1 pi over 3. Remember, inverse trig is giving me the angle, inverse angles. But I have restrictions, again, on what my answer can be. On letter C, inverse cosine again. So again, before I even look at the number, I go, all right, inverse cosine crosses out the bottom. I ask myself, what angle would give me an adjacent of root 2 over 2? Well, that's conveniently the 45. And since it's a positive, I must be in the first quadrant. I know the adjacent length is root 2 over 2 for this, that one right there. So the final question, or the final answer is, what is that angle? That angle is 1/4 pi over 4. Again, we have a whole series of these. On letter D, now I'm doing inverse tangent. Inverse tangent is just like inverse sine. I cross out the left side. Also notice that it's negative, so I know I'm going to be down in the fourth quadrant. Now, tangent, sometimes we have a little more trouble with. I need to figure out what angle has a tangent of root 3 over 3. Well, going back to my two special right triangles, if there's a root 3 in my answer, I know I've got to be dealing with the 30, 60, 90. The question is, would I be going from the 60 and doing opposite over adjacent, or the 30? This one turns out it's the 30. If I do tangent of 30, opposite is 1/2. Adjacent is root 3 over 2. If I multiply by the reciprocal of that, 2 over root 3. 2's cancel. That leaves me with 1 over root 3, which finally, if I rationalize it, times top and bottom by root 3. Oops, getting some not very well written stuff here. I end up with root 3 over 3, which is what I wanted. So what did I just figure out? I figured out that from 30 degrees, the tangent is root 3 over 3. So I know this is a 30-degree angle reference, and I know it's in the fourth quadrant. So then the question is, what is that angle? And again, I'm rotating in the negative direction. That would be negative pi over 6. On letter E, inverse sine. So immediately I cross out the left side. 0, well, 0, that's nice. That means I'm going to be on an axis, actually. The sine is 0 when the spinner doesn't go anywhere. This is the coordinates 1, 0. And remember, those go cos sine. The sine is 0 when the rotation is 0. Now that one seems kind of weird, but that is an angle. It's just an angle of 0 radians. And again, if you're getting confused on these, like let's look back at letter D, think of them as regular trig. I'm saying the tangent of some angle, which I decided was negative pi over 6, would give me negative root 3 over 2. Oh, sorry, negative root 3 over 3. Negative root 3 over 3. So basically think of these two things switching, and it's regular trig. On letter F, inverse tangent again. So inverse tangent, we cross out the left. Now be careful, when tangent is 1, that's actually not on an axis. Tangent is 1 on a 45. Because the opposite and adjacent are the same length. So that angle is pi over 4. On letter G, inverse sine. So again, before we even look at the number, inverse sine, I cross out the left immediately. -1 for sine is going to be on an axis. That one is actually straight down because the coordinates are 0, -1. And again, the y coordinate is the sine. But again, remember, the question is asking me what is the angle to get to there. That angle would be -pi/2. And again, think of it as regular trig. If I asked for the sine of -pi/2 radians, that would spit out an answer of -1. This is just reversing the process. That's what inverse does. Letter H is an inverse cosine. Cross out the bottom. Again, we've got a -1. Well, the only spot where cosine is -1 on the unit circle is when my spinner's over here. That's -1, 0. So the cosine is -1. And again, it's asking me for what is the rotation to get to there. And that is pi radians. For letter I, inverse tangent again. So I cross out the left. This one's positive, so I know I'm in the first quadrant. And it's just √3. Going back to our special triangles. Well, if 30° gave me √3/3, I've got a sneaking suspicion that 60° is going to give me just √3. So if I go from the 60°, opposite is √3/2. Adjacent is 1/2. If I multiply by the reciprocal, 2's cancel, and I'm left with √3, which is what I wanted. So what I just figured out is that 60° gives me a tangent of √3. So this would be a 60° in the first quadrant because it's positive. That angle is 1/6, 2/6, 2pi/6, which reduces to pi/3. All right, we'll finish up this lesson on the next video.